Now these circles, now see, this has given one electron, this atom has given one electron. Both these electrons are circle, means sharing. They are shared by this atom as well as by this atom, and in doing so, they both are actually acquiring what? 1s2 configuration, which is their period's noble gas configuration. And in doing so, this becomes very stable. So this is how the sharing of the electrons takes place. One pair which is shared leads to the formation of one covalent bond, which is indicated or it is drawn in the form of a hyphen or a line between the atoms. So we can draw a hydrogen molecule like this, H bond H, which is a normal covalent bond. Let us see some other examples. Let us take example of HCl molecule, hydrochloric acid or hydrogen chloride. In this we know H has one electron, 1s1. Chlorine has two, 8, 7, like this. Now what happens is, they cannot, they doesn't involve the transferring of electron, these two. The reason is hydrogen is also very small in size, it has high ionization energy, so it won't be losing electrons very easily. So what they do is, they try to share their 1 electron, so that this also attains helium's configuration and this also attains its own period's noble gas configuration. So what they do is, they try to share it like this. Usually Lewis used only the dots. I am using star for the electron of the hydrogen in order to make it very clear to you that there are two electrons which are shared between hydrogen and chlorine. One of these is of hydrogen, another of this is of chlorine, and this is how it is in the stable helium noble gas configuration. It is also attaining its octet complete. So this is how they both become very stable. So this molecule can be in a very simple way represented like this. Let us take some other examples. Like we can take example of water molecule. Oxygen has, this is one hydrogen, if we can write it like this, it has, the oxygen has 6 valence electrons, it has only one. This hydrogen is also having one electron. When these three atoms combines, hydrogen shares one electron with oxygen. This oxygen also shares one electron with another hydrogen, because oxygen needs 2 electrons to complete its octet. So what we notice is that this oxygen is sharing what? 1 electron with the neighboring the hydrogen atoms, and this is how its octet gets completed. So this is most important to note that hydrogen, water in this case is forming one bond with this hydrogen and one bond with this hydrogen, which is represented like this. And in doing so, it is acquiring 2-8 configuration, it is acquiring 2 electrons, and it is also acquiring 2 electrons. Another important thing, the bonds, the pair of electrons which participates in the bond formation is called bonded pair. It's called bonded pair. And the pair which doesn't participate in the bond formation and is present as such on the central atom or on the other atom is called lone pair. These are the usual terms which we use. So in water, oxygen has 2 lone pairs and 2 bonded pairs. So this is how we can explain the formation of different molecules. Now, after understanding the formation of covalent bonds by the help of Lewis-Langmuir concept and by the Lewis dot structures, let us understand that it is not only the one pair which is always shared between 2 atoms. It can be more than 1. It can be 2 and it can be 3 also. So let us take the examples where we find we have multiple bonds. Multiple bond means single, not only single, we have double or triple bonds. So let us take the example of first the double bond. Most important example and the simplest we can take is of oxygen molecule. See, each oxygen has 6 valence electrons. It's 2, 6, 2, 6. Now, they both need 2 electrons to complete their octet. So what they do is they share 2 electrons at one time with each other. So what we find is oxygen like this is having this kind of a sharing. So since 2 pairs are shared between 2 oxygen atoms, we can draw it like this. Double bond oxygen. And these are the 2 lone pairs each oxygen is having. And these are the 2 bonds which are present between 2 oxygen atoms. So this is an example of a double bond which is present between 2 atoms in a molecular species. Let us take example of a triple bond. Now triple bond, the best example is the nitrogen molecule. We know each nitrogen has 5 valence electrons. So it is short of 3 electrons. This also is short of 3 electrons. When these 2 are allowed to combine, they cannot will be able to complete their octet until and unless they shares not only 1 pair, not only 2 pairs, but simultaneously 3 pairs. So what we find is they are sharing these 3 pairs like this. So what they have is, this is what are the 3 pairs which are shared between 2. These are so each nitrogen is having 1 lone pair and 3 bonded pairs, and we can draw this molecule like this. So it's called triple bond. So nitrogen molecule has triple bond, oxygen molecule has double bond. We can also have, so these are the examples of the molecules which are having multiple bonds. We can also have these type of multiple bonds in some bigger molecules also. Like, I can give you an example of ethene molecule. In ethene, the formula is C2H4. What we find is we have a structure like this. Let me draw the Lewis dot structures first. So in this you can find that like these are the 2 hydrogen atoms, 2 and with each carbon, which are completing their 2 electrons, and this is the sharing of the electron which is taking place, and it is like this. So each carbon 4, 5, 6, 7, it is completing their octet. So what is, and this is the 2 pairs which are shared between 2 carbon atoms. So what is the representation of this molecule is 2 bonds between 2 carbon atoms, 1 single bond with these 2 hydrogen atoms like this. So this is your simple ethene molecule.